Hello all, this is going to be a recap of our last class at Code Your Future in Glasgow. In this class, we started adding database to what we've been doing so far. So in the last few weeks, we have been building a dynamic application using MongoDB. We added functionality, reading some posts and showing them from the file system. But as we talked, reading and writing from the file system is not a good solution for any real application. There are so many problems with that approach. It doesn't scale well. You cannot have a large number of users. You don't have a structure for the data that you have in a file system. It's not easy to query, to maintain, and that's why developers and any application uses a database system. Traditionally, these databases used to be relational databases. They are basically the fundamental building blocks are tables and rows and so on. But in the last few years, a different type of database called non-relational database or NoSQL became very popular. And we are going to start with the first for the next few weeks with MongoDB, which is a non-relational database that is the most popular type of this flavor of databases. We started by installing Mongo, and once you have it installed, you can run the database server from your terminal by running mongod command. And once we have that, we can interact with our Mongo databases using the Mongo shell. You can run commands. DB tells you which current database we have. We started by using a new database called profile. When you say use profile, that switches to the database and it creates it once we start adding collections to it. Collections are the basic storage, the first concept that we encountered in dealing with the database. So we can create a collection for students, for example, and each collection will have records or documents. So we can have a document called for a student. It can have a name Itza, for example, and this adds a document to our collection which lives in the database. So we have, in this step here, we have a database called profile, we have a collection called students, and the students have one document called which have the data for Itza. So if I want to query it, I can say db.students.find, and that will give me all the records. We notice that Mongo added an ID, which is an identifier, a unique identifier for each record. If I want to add more than one record, I can say insert many and give it an array of objects. Can have another name, Muhammad, and that will be one record. And we can have another document with another student, Johannes. Now if I query the database and say give me the count of all of these, okay, faster. I can check the documents that I have, how many I have. I have one document in that collection. I can also add multiple collections, multiple documents, which is just simply an array of .json objects. Each one can have, for example, a name, and the other one can again another one with a different name. Then if I insert, now if I check the students, I have 3 students. If I query them all, I'll get the records. See again, each one has an ID. I can for find, I can give it a query parameter, which is again a JSON object. I can say give me everyone whose name is Itza, and it gives me the record, one record there. I can also give it a regular expression, just give me any record that have name with has the letter E. Get me Etsa and Johannes because they have the letter E, and the I at the end tells it that are case insensitive. If I didn't put the I, then it will be case sensitive. In this case, I only get Johannes. So it gives us a database system that we can query efficiently. We can have all kinds of very complicated queries with the database. It gives us, we already saw that it gave us IDs for every record. It uses for the documents a format called JSON, which is very similar to JSON, but has some more improvements to make it more efficient for the purposes of databases and data storage. The query that we add themselves, they're also documents that are JSON based, and it's a very powerful system. So we know a bit about Mongo, how to interact at collections, databases, and documents. Let's now try and hook up our Mongo applications that we've been building in the last few weeks to this database storage. First thing, we forked and cloned the project that's available on CodeYourFuture. And then once you have it locally, we run npm install, which I've already done. And to run it, we just run the command npm. We can't say npm start, but we added also a special script to say npm run dev, which is defined in our package.json, and it runs it using nodemon, which auto-reloads the site whenever we change a file. Site controller is where we have the route for the index page, the slash. If I go and refresh, I have it running here. And right now what it does is that it reads a post.json file that exists locally on data. It has some posts, and it reads them from the file system and then send them to the index view to be rendered. This approach, as we said, is not scalable. The best way to do this kind of storage, reading and writing, is to use a database system. So since we're starting to learn about Mongo, we will move from using the file system to actually connecting to a proper database. The first thing that we need to connect to the database is to install a MongoDB package. I added the save flag, so that's added to our package JSON here. Then once I have that, I can I will require MongoDB and ask for that retains an object that has a couple of methods and other objects, and we just use the Mongo client for now. And I will go and just delete all the content of that route now and add this code that connects to the Mongo database. As you see there, we have a Mongo connection, and that has the connection string. Connection strings have a special format. All we need now is just localhost. That's the server that we're connecting to, and the port. This is the default port that Mongo runs on. We're connecting to a database called profile that we just created on the Mongo shell. And then here inside the root itself, we call connect on the Mongo client, giving it Mongo connection, which is this connection string. And then we have a callback that gets called once we connect to the database. Like we said, it's convention in Mongo that the first argument in a callback is the error, and then if there is no error, if it's null, that means the operation was successful, and the second argument will have, in this case, it will have the database that we just connected to. And then on the database, we ask for the collection called posts that we are going to just create, and we ask to find everything. We're just passing an empty object, so in a query string, and that means give me everything. And we call to array, and that one also takes a callback. Again, the first argument is an error. The second argument will be whatever is returned from that query, which is not students, is post. In this case, let's give it a better name. Once the callback is called, we can close the database connection. We don't want to leave our connections hanging. And then we can send back the posts that we got. You see when you copy paste code, you get things that you shouldn't do. This rest.json, it sends back a JSON, which we use in our APIs, but in this case we want to render a view, and this is the right code for doing that. So we give it post here, and in ES6 we know that we can omit this, but for now let's just leave it. So now we connected the database, we got our posts, we send them to the view index. Let's also change the title that we show on that. Let's say this is MongoDB post, and the subtitle, a modern site driven by a database. This is basically just rendering the view here, index, which expects posts and show them to the user. Let's now go to the browser and refresh. We have our title, it picked our changes, but there are no posts shown because we haven't added anything to our database. We don't have a post collection, so we are now still in the database called profile. We want to create a collection called post, and we will insert many, and we'll just go ahead and take this JSON, which is an array of documents, of objects. Once we said insert, it's inserted successfully. Acknowledge true here. So now if we go and just to make sure that we're not using this anymore, we will delete this post JSON. Now it's deleted, and I'll go and refresh, and you can see we have these now are coming from our database. So we have our database that contains the posts. It's up and running. We're connecting with Mongo. we know how to connect from the shell as well. If we say db.post.find, we'll get the post that we added, and Mongo again added an ID for them. We can also use a graphical tool to connect to the database. So now I'm connected using MongoDB Compass. I'm just connected to localhost to 27017, and it is showing me the databases that we have here. Let's refresh our connection. So we see that our profile database was created. It has two collections, post, which has 4 documents. So this is just a graphical interface to make dealing with the database easier, to make sure that we are actually getting our post from the database. Let's say here, this is very smart post about Mongo. Just update this. All of this operation we can do from the shell as well. But now if we go and refresh, it's indeed getting its data from Mongo. So we have it updated here. And this is a database driven website now. It's not just HTML. You have a website, built-in node, a web application, and it gets its content from a database. Good, so now just let's commit what we've done so far. We connected with Mongo. So next step, let's have links to the details of each post. Remember, this one now has a link that goes nowhere, but we want to be able to click on a post and then take us to the details of that post, the full contents, not just a summary. So to do that, we will have a second route called that has slash, and then it takes a parameter post ID. So this will be based on which post we click on. And because Mongo already added for us an ID for each one of these, this will make it quite handy. And just instead of having post ID, I will have the word post dash then post ID, so that doesn't conflict with the other routes that we have here. And then the route will have the same. We'll use AS6 syntax arrow functions. I will copy paste this similar code to this here, but we want first to be able to get the post ID, and that we can get from request.params.postID. This is basically, this matches with this, whatever word we use here. So if I said here, if it's camel case, then here it should be camel case as well. It just matches with that. So then we get hold of the post ID, and then we connect to Mongo to post. And this time, instead of finding all the collection, we just want to get the one with ID, post ID. We can actually, since the ID is a special one, we don't have even to pass it an object. We can just post ID. We call to array, and we will render a new view called single post, and we will pass it the first post that we get. Okay, so this should be rec and res, of course. And to be able to match by ID, we just have to require a special object called object ID. That's again, it's provided by MongoDB package. Okay, and then we should give object ID and then post ID that we got from the query parameters. So now the next step will be to actually change the views. First of all, here the link, we want to link to the formats that we decided. So it'll be post dash and then post ID, it'll be post dash, and then we can get this dot underscore ID, and this from the object will get us the ID. So now if I refresh the page, and we can see that the link is connecting to post dash and then the post ID. I have an extra here, we don't need this $sign, so if I just take it out, so now let's create the single post view. It will be very similar to this index one. Just I'll create a new file under view called single view.handlebars, and we should call this post, so we'll pass just the first post from what we'll get back, and in the single view here we'll get it as we just display, instead of this will be post.title, but instead of summary we will show the actual contents of this object. So if we look, this is called content, and now this should work. If we go to our website, refresh this, when we click we will go to a view single post. It has the HR and it has the full content of that page, and you can see the URL. It has post dash and then the ID of that specific one. If I go back and click on another one, then it will take me to the content of that one because it has a different ID. So let's look back at the code for doing this. The first thing is we define the parameter, which just shows that it has this fixed string /post at the beginning, and then dash, and then whatever comes after express will take it and put it in rec.params.postID. Post ID is just that it matches with this one. If this called it here ID, then we will call it here ID as well. And then we do the similar code to what did before. We connect to Mongo using the connection string. We instead of passing an empty query string, we pass an object ID, and because ID is a special one, we don't have to put it in an object, but we could have also just done it like that, and that should also work the same way. I forgot to put this back as post ID. I'd like to see this should match, as I said. Now if I refresh, this works. So we just pass the query here that says ID. This is the name of the field in the Mongo database, dash underscore ID, and we give it our post ID. We wrap it with this object ID that we got from MongoDB, and then similar to the first one, we just call to array and we'll get posts. We could have also used a method called find1 instead of find, but find returns an array, but we're only interested in one of them, so we just get the first element in that array and we pass it to the view called single post in a value called post. So maybe even here what we should do is, instead of passing a title, fixed title, we should have the title as the one that comes from the post itself. And if I refresh this, look at the title. Now the title comes from the actual database as well.